Salutations, mini mathematicians! I'm going to go over dot B in this video. Now, if you can see Pi, she's here too, ready to go over some Pythagorean Theorem proofs. She loves them. So let's take a look. So number one, it talks about which statements below will be needed to start this proof of the Pythagorean Theorem. So the Pythagorean Theorem is, if you have a right triangle, it has to be a right triangle with side lengths, leg lengths A and B, and the hypotenuse length C, then A squared plus B squared will be equal to C squared. And so when we're looking at a proof, we're going to be typically looking at the shape, and we're going to be looking for the area of the larger shape equal to the sum of the areas of the shapes that make it up. So for number one, we're going to have the area of the large square, which has side lengths A plus B. And then we're going to be looking at all the parts that make up that square. And that's going to be the square in the center, which has side length C. And there's going to be 4 of these triangles that are right triangles. They're congruent, and they have leg lengths A and B. Okay, so what we're going to be looking for in our multiple choice here is I'm going to be looking for statements that have to do with the area of this square, and that's going to be A plus B times A plus B. I'm going to be using C squared because that is the area of this square. And I'm also going to be using, 1/2 times A times B, and there's going to be 4 of them. So I'm going to be using this statement as well. Cool. Talking about why we wouldn't use the other ones, we're not going to use C squared plus A squared plus B squared because there's no shape that has that area. We're not going to use 2/1/2 A times B because there's 4 right triangles that are congruent, not just 2. And we're not going to use 1/2 times A plus B times C because there's no triangle that has one side A plus B and one leg length C. So let's take a look at the next proof. Looking at the next proof, we have a trapezoid. So we're going to have the area of the trapezoid. And remember, area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So here, our bases are going to be the lengths that are parallel to each other. So A and B are base 1 and base 2. And then our height is actually going to be these right angles. From here to here is the height. And notice on that picture, that is going to be A plus B. So height is A plus B. So that's going to be the area of that trapezoid. And that's going to be equal to, we have one triangle here that has, it's a right triangle, C and C. And then there's 2 of these other right triangles with leg lengths A and B. So this is going to be 1/2 C times C, which is C squared. And this will be 2 triangles that are 1/2 A times B. So let's take a look at our options here. We are going to not just select C squared because there's no square that has side length C. We're going to come down. We're definitely going to pick 2 times 1/2 A times B because that represents our 2 small right triangles. We're going to pick 1/2 times A plus B times A plus B because that represents the area of our trapezoid. We can think about that as 1/2 times a plus b times a plus b. And we're also going to pick 1/2 times c squared, representing that other triangle. Cool. And let's take a look at that third one. What type of triangle is used in the proof below? What type of triangle does that have to be? It has to be a right triangle. It's the only triangle that the Pythagorean theorem has to use. So it has to be a right triangle. It could possibly be isosceles or scalene, but notice, taking a look here, equilateral, acute, obtuse. An acute triangle can't be a right triangle because all those angles have to be less than 90 degrees. An obtuse triangle can't be a right triangle because one angle has to be greater than 90, which means the other two angles will have to be less than 90. And equilateral triangles cannot be right triangles either. So right triangle is your best and only option here. Fabulous. That concludes going over dot B. Thank you for watching.